Good morning, everybody. Welcome to the next to last lesson of the year. So before we start this lesson, the lesson's going to be section 10.4. I just felt like I needed to explain kind of why I've jumped around all over the place with chapter 10, so that you can just understand a little bit better where we've been, where we're going, and just so you know that the order is purposely out of order, and I want to explain why. Okay, so chapter 10. The topic of that chapter is about area. So if you look at all the sections, these three sections give you area formulas. Those are for triangles, quadrilaterals, and regular polygons. And then 10.4 is the one that we're going to do today, and I'll come back to that one. 10.5 is area formulas of the other regular polygons, the ones that require trig. And then 10.6, we skipped it and came back to it, and I'll show you why in just a second. And then 10.7 was area formulas again of circles and then parts of circles. And then because geometric probability involves area, it's at the end of that chapter. So here's what we did in chapter 10. We did all these area sections, all the sections that were just area formulas. We did those with the addition of the geometric probability because area is the background for it. All right, so the reason we skipped over these is because they decided when they're talking about area in chapter 10 to put in a section about area of similar figures. And so that takes the area topic that we were talking about and adds in the chapter 7 content, which is a little while ago, and it kind of just gets off course of just talking about area. And then there's a section in chapter 11, which is the one that we're going to do for the last lesson of the year. And that section, 11.7, is volume of similar figures. Volume and surface area of similar figures. So the reason I skipped lesson 10.4 is because I think these two sections go together because they're talking about similarity. And when we get to the last lesson tomorrow, you'll see how well those go together and why I think they should be learned together. And then the other one I skipped that we picked up on circles is where they talk about circumference and arc length. So to me, that just did not go with the area sections. And since there was a whole chapter on circles, that's why I moved 10.6 into that chapter when we learned about circumference and arc length. And the only reason they teach about measure in that section in 10.6 is so that you can find arc length, because measure is required to find arc length. So I say all that to say the skipping around is on purpose. These area sections were all done in chapter 10, and then the circle, arc length, and arc measure and circumference, I think goes more with circles than area. I think the authors put it with area because there's a formula for it, just like there's a formula for circle area. But I think that goes more with circles, so that's why I moved that to the beginning of the chapter on circles. And then finally, I moved this one to join with section 11.7 to talk about similarity all at once with these area topics and volume and surface area. All right, so all that to give you a little background about why on earth I skipped around. Okay, if we were at school, I would start off by giving you this problem right here. Let me hold it up where you guys can read it. Okay, so if I were you, this would be a great idea for y'all to pause the video and try this problem right here. It says carpet for a 10 by 12 room, that's in feet, 10 feet by 12 feet, costs $600. Another room has dimensions that are 3 times the first room. How much will it cost to carpet the larger room? So it'd be a good idea for you to pause, try that problem, and then press play again. Okay, so let me talk about this problem. So if this problem were on, let's say, the SAT or something, a lot of people think, well, if the smaller room costs $600 and then the bigger room is 3 times the first room, they'll just multiply 600 times 3 and put that it's $1,800. And $1,800 will be one of the choices. And then some people do a little more with it, and they multiply 10 by 12 to get the area of the room. See, the carpet is going to cover the entire area of the floor. Carpet, doesn't go around the edge. So we know it's an area problem. And since it's a rectangular room, the area is 120 square feet. And then they'll figure out how much it's costing per square foot. $600 is for the whole room. So $600 divided by 120 is the cost per square foot. And then they'll draw the room that's 3 times. Now it says dimensions 3 times. So they'll draw the second room. And if the dimensions are 3 times, that means it's 30 by 36. And they'll find that area. And then use the cost per square foot to calculate the carpet cost. Okay, so let me show you an easier way to do that. But that's the correct way to do it. It's the correct way, but the long way. So here is another way of looking at this. This is our 10 by 12 room. I scaled it, each space is 2. And so this is that original room. It's $600 to carpet it, right? It says the dimensions are 3 times as big. So that means this dimension is 3 times as big. And then this length is 3 times as big. 1, 2, 3, 4, 5, 6. Okay, so you can see from this graph paper that the room itself is not 3 times as big. The dimensions, each dimension is 3 times as big. But that made the room itself, so the second room, 9 times as big. And you can see that here. So if we increase or if we scale both dimensions by 3, so this length is 3 times as big and this width is 3 times as big, then the area is 9 times as big because 3 squared is 9. Okay, so here's what that means. That means the cost to carpet the room, if this much carpet costs $600, then the cost of carpeting that room is 9 times as much. Not 3 times as much, but 9 times. So it's $5,400. That's what today's lesson's about. Okay, here we go. So these are the notes papers that you need, or notes paper. And here is the lesson. There's a theorem that says if the scale factor of 2 similar figures, keywords, they have to be similar. The scale factor of 2 similar figures is A over B. And so if you think back to chapter 7, scale factor is the ratio of the sides. Ratio of sides. Sometimes they call it that. Sometimes they call it scale factor. Sometimes they call it similarity ratio. So if the scale factor of 2 similar figures is A over B, then the ratio of their perimeters is also A over B. So we've got A over B for scale factor, A over B for perimeters, and the ratio of their areas is that scale factor squared. So that's the new stuff for today. All right. So because the theorem gives me 3 ratios, I like to write a little chart for each problem just to organize my thoughts. And this one I put an SF for scale factor, this one I put a P for perimeter, and this one I put an A, capital P, for areas. And that's where I put my 3 ratios, scale factor, perimeter, areas. These are going to be the same. Those are always going to be the same. So some people like to put just 2 columns. That is completely up to you. For scale factor, perimeter, and then area like that. Because these 2 are going to be the same. All right, example 1. It says find the ratio of the perimeters and the areas of the 2 similar figures. So first thing you need to note is they are telling us they are similar. They're not asking us. We know ahead of time that they're similar figures. So this theorem applies. And so I'm going to make my chart. Scale factor, perimeter, areas. And they want to know these two ratios, the perimeter ratio and the area ratio. And the scale factor comes from looking at the two figures. And so if you think back to chapter 7, which has been a while, I realize, the scale factor is found by finding two corresponding sides of the two similar figures. So that bottom line corresponds to that bottom line, and writing a ratio of them. So the scale factor is 7/21. Okay, scale factor should be reduced, and 7/21 reduces to 1/3. So that is the scale factor, 1 to 3. And then I'm just going to fill out the rest of the chart. The ratio of the perimeters is 1 to 3. These will always match. And the ratio of the areas is the square of that fraction. It's 1 squared over 3 squared. That's the ratio of the areas. So that's 1 to 9. And that's like the problem that we just did. Because of the two rooms, the dimensions were related 1 to 3. So the area was related 1 to 9. Okay, so if this were like a test question or something, then I would list those answers in that order. I would say this answer is 1/3, this answer is 1/9. Okay, you stop with the chart whenever they're asking you to find the ratio. You have no more to do when they ask you for ratio, because the ratios are in the chart. These are the answers. Okay, example 2. It says trapezoids are similar, so again, we don't have to determine that they're similar. The problem tells us. And it says the area of the smaller one is 12. I'm going to write that in here. 12 centimeters squared. Find the area of the larger one. Okay, so this is what a lot of people do, and they make mistakes on this question. And this is how. They'll put 6/8, so side to side, equals 12 over x, area over area. And that does not work because of this part of the theorem right here. So I'm going to write this chart, and I'll show you what I mean. So here's the chart. This column is for scale factor, this column is perimeter, this column is area. Scale factor comes from here. The scale factor of the two similar figures is 6 to 8. So 6 to 8. That reduces to 3/4. 3/4. Now for this problem, we don't really need perimeter because it's not asking us for perimeter, but I just make this little chart for every question. 3 to 4, 9 to 16. Remember, you square both of them, the top and the bottom. That's how the areas are related. So see, if you're going to write a proportion for this problem, you can't put 6/8 equals 12 over x, because the sides are not proportional to the areas. The squares of the sides are proportional to the areas. So you have to go 6 squared over 8 squared equals 12 over x. And 6 squared over 8 squared reduces to 9/16. See, we get it from this chart. Okay, so here's the moral of that story. If they're similar figures, I make a little chart of how everything's related. And then since it's an area question, find the area of the larger one. They're asking me for area. I know to use this fraction because that's how the areas are related. That's what this chart gives you. What's the ratio of those areas to put in a proportion? All right, so I go 9 over 16 equals 12 over x. And the reason I put 12 on the top is because when I wrote 9 to 16, it's small shape to big shape. So when I write area to area, I have to write small shape to big shape. So it does matter which one's on top. So probably the most frequent mistake with this, besides going 6 to 8 equals 12x, is putting the one of the fractions upside down, or putting the second fraction upside down. Okay, let's solve that. So 9 times x, 9x. 12 times 16. 16 times 12 is 192. And then divide that by 9. Divide 9. 21.3, roughly. So x is approximately 21.3 3 centimeters squared. Okay, let me make sure I did that right. 6/8 reduces to 3/4. And that squares to 9/16. I wrote down the right number. I'm just double checking myself. Sometimes I don't remember, like an answer didn't sound familiar from when I did it before. So 12 times, just double checking. Yeah, okay. So that is the area of that larger trapezoid. All right, this is just like the problem we did to start the lesson on that problem on carpeting. It says a scale factor of 2 similar wood floors. So wood floors, and they're similar. So here's our wood floor, wood floor. It says their scale factor is 2 to 3. The cost of refinishing the smaller one is $320. So see, it's like that carpet problem. How much will it cost to refinish the larger floor? So this would be a good place to pause the video and try this problem. But here's what you don't do. You don't go 2 to 3 equals 320 over x. Don't do that. See, you have to, since you're talking about area, you have to square the scale factor. So in our chart, the scale factor, the perimeter is the area. The scale factor is 2 to 3, so the perimeter is 2 to 3, and the area is the square of that, which is 4 to 9. That's how the areas are related, 4 to 9. And now, one thing about this word problem, see, this mentions the area. Find the area of the larger one. This one just says you're refinishing a floor. So you have to kind of infer that you're talking about area because you don't put wood flooring around the perimeter of a room. You actually cover the room with the flooring. So that's why it's an area problem. All right, so we pick our area ratio from our chart. So the chart gives us these ratios, and we're picking this one because it's an area problem. If they were asking me about like baseboarding or crown molding, I would use that ratio, the perimeter one. All right, so 4 is to 9 as 320 is to x. And then you cross multiply and solve that. 4 times x is 4x. 9 times 320, 320 divided, or times 9. Times 9. 2880. And then you divide by 4, and you get, I think that's 720. Yeah, x is $720. And that is how to do that one. That's how much it would cost to refinish that larger floor. Okay, these two problems are very similar questions. So I'm going to do this one, and then you may want to pause the video and try this one. So it says 2 similar pentagons have areas of 25 centimeters squared and 4 centimeters squared. Now, when some people read this, pentagons, an area, they start trying to figure stuff. Remember in chapter 10, we learned the formula, 1/2 perimeter times apothem, and we had to calculate this apothem. And they start trying to do a lot of work there. But you don't have to be figuring the area of the pentagons. They told us these areas, and we're just going to use those areas to find the ratio of the sides. That means scale factor. So you may want to write that down. Ratio of the sides, that is scale factor. That's another name for that. And of their perimeters. So here's what I'm going to do. Since they're asking me about ratios, I'm just going to use that chart. But the difference is they're giving me this one. See, this is scale factor. This is perimeters. This is areas. They gave me 2 areas. 25 to 4. You can write 4 over 25 if you want. I just write the order that they give me, right? That's the areas. So here's the question is they're asking us for this ratio of the sides, scale factor, and this. And we know they're going to be the same answer. We just have to find it. All right, so here's what you got to think about. Whenever they give you this one, This one is squared already. See, it's the ratio of the areas, and areas are square. See, centimeter squared, centimeter squared. So to get the earlier ones in the chart, to get the first two columns, we have to unsquare that. And unsquaring means square root. So they're squared already, so do this, square root. So these two answers are square root of 25 over square root of 4. And luckily, those are nice, and they have nice, pretty square roots. So this is 5 halves. 5 halves. So the scale factor and the perimeter, their ratio would have to be 5 to 2 to make the area ratio 25 to 4. All right, you can do this one the same way. Now, the trickier thing about this is that if you look at these numbers, 48 and 147, they're not numbers like 25 and 4. See, when you take the square root of those numbers, you don't get nice, pretty whole numbers, except if you reduce it. So let me show you what I mean. So here's our chart, scale factor, perimeter, areas. Again, they're giving us this. They're giving us this one. Two similar triangles have areas. So this is our area ratio, 48 to 147. That one is squared already. So we have to square root it. But square rooting these numbers would be very ugly. So if you reduce 48 over 147, those were the numbers, right? Yep. If you reduce it, see, look, it reduces to 1649ths. And those just happen to have pretty square roots. So this is the same thing. Now, remember, I did not square root this yet. I just reduced it. See, some people reduce it and they get confused and they think they've done something that would give them these already. But all I did was write the reduced version of 48 over 147. So then, to get these answers, use square root. So square root. Square root of 16 is 4. Square root of 49 is 7. So these are 4/7. Now, suppose you didn't notice that. What if you looked at 48 over 147 and you just forget about reducing, or maybe you think 147 is prime or something. What if you just forget? Well, you can do it this way. It just takes more work. So I just want to show you that real quick, just in case you forgot to reduce. You do know that you have to square root the area to get these other ones, right? And if you break down the 48, now remember, if you remember to reduce, you don't have to do all this. It breaks down like that. And then we look for twins. So a 2 comes out and a 2 comes out. So 4 comes out. And that 3 would be left in. This is just back when we learned to reduce, or not reduce, to simplify radicals. And then 147, 2 doesn't go in there, but I think maybe 3 does. Let's see. Yep. So 3 goes in there 49 times. 3 doesn't go in there, 5 doesn't go in there, but 7 does. And we get this. And we have twin 7s, so a 7 comes out, and that 3 gets left in. And so then look what happens. You have 4 square root of 3 over 7 square root of 3. Those cancel. So see, we took the square root of the areas, and we didn't notice that it reduced, so we broke them down, and we still got 4/7. Okay, so that's just the long way to do it if you don't notice that it reduces. Or if it doesn't reduce, it's possible that you get one that doesn't reduce. All right, so one thing to remember about this lesson is if they ask you for ratio, your answer is in the chart. If they ask you to find an area or to a calculation that involves area, that's when you take your fraction from your chart and you write a proportion and solve it. If they give you the area ratio and ask you for the other ratios, you have to square root it because they're giving you the one that's squared already. So that's a little summary. All right, that is all to lesson 10-4. Y'all have a great day. One more lesson of the year. Y'all have a good day. Bye.